Alright, in this example, we're going to look at how to solve a polynomial inequality. Here we have a cubic inequality, and the first step is we're going to have to make one side 0. So we're going to bring the 11x over, and the negative 12 comes over, and what is that going to give me? X cubed minus 2x squared. That'll become negative 11x, and the 12 becomes positive less than 0. All right, now that we have one side 0, we're going to have to get this polynomial factored. Now the problem is the standard technique when there's 4 terms is factor by grouping. However, factor by grouping is not going to work in this case. It's just this is not going to factor by grouping. And so we're going to have to use some advanced math techniques here. So the first technique I'm going to use is called the rational zero theorem. What that says, it says if you take all the factors of the constant divided by all the factors of the lead coefficient, and then look at all of the possible combinations of the divisions there, you'll get all of the possible rational zeros, which is one way that you can, well, get the thing factored. Okay, so here we go. Let's do the rational zero theorem. So, all of the possible factors of 12. 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 5, 6 goes into 12, and 12 goes into 12. So those are all of the possible factors of 12. Now we need to divide those by all of the factors of the lead coefficient, which is 1. And if you think about it, if all of those numbers are divided by 1, then it's just going to be the same numbers. So these are all of the possible rational zeros. The next advanced math technique we're going to employ is synthetic division. And what synthetic division will do is help us figure out if any of these possible rational zeros are actually zeros. So for synthetic division, we're going to start with the little box here. And we're going to pick one of these numbers, one of these possible rational zeros to go in the box and then execute the synthetic division. All right, out here to the side, we've got the coefficients, 1, negative 2, negative 11, and positive 12. And we're going to pick, I'm just going to randomly pick one of these 12 numbers here. And if you're wondering why I said 12, it's because there's 6 numbers, but it's plus or minus 6 times 2 there is 12. All right, so let's start with 3 and see if 3 is a 0. So the 1 comes down, 3 times 1 is 3. 3 minus 2 is 1. 3 times 1 is 3. Negative 11 plus 3 is negative 8. And 3 times 8 is 24. And that is not 0. This needs to be 0 here, and that's not 0. So that tells us that 3 is not a 0. All right, so if 3 doesn't work, maybe negative 3 does. Let's try negative 3. And again, I'm just picking randomly here. 1 times negative 3 is negative 3. Negative 3 and negative 2 is negative 5. Negative 5 times negative 3 is positive 15. 15 minus 11 is 4. Let's see here, that's 4. And 4 times negative 3 is negative 12. Oh, and that does make 0, okay? So what that tells me, it says I found one of my factors. If negative 3 is a 0, what that says, it says x plus 3 is a factor. And these 3 numbers here are the coefficients of the other factor, okay? So that's going to be x squared minus 5x plus 4. That is the other factor. And if you're wondering why was it x squared, it's because the original problem was x cubed, And when you find a zero, when you find a factor, it knocks that remaining factor here, those terms, it knocks it down by 1. And now we're going to try to factor the remaining trinomial. And this should be a little bit easier here. Oh, and why did I put equal to 0? That should be less than 0. All right, so the signs are both going to be negative. X and x to give me x squared. Numbers that multiply to make 4 and add to make 5, 4 and 1. And so now we have it factored completely. Now we can set each factor equal to 0 and get our critical points. So x is -3, +4, and +1 are the critical points. And the next step is to take those critical points to the number line. Make sure we get them in the right order here. -3, 1, and 4. And since that is strictly less than, then these are going to be open circles. And then we're going to need to pick test points, okay? So we need a test point that is less than -3. How about -4? We're going to need a test point between -3 and 1. How about 0? That's in there. We need a test point between 1 and 4. How about 2? And then we need a test point bigger than 4. How about 5? There we go. So how many test points? 1, 2, 3, 4. And I highly recommend that when you test those, you plug them back into the factored form. It's going to be a lot easier to plug back in where it's factored. All right, here we go. Testing -4. -4 plus 3. -4 minus 4. -4 minus 1. And we want to know, is that less than 0? So that's going to be a negative times a negative times a negative, which ends up being negative. And notice I don't really care what it is. I just want to know if it's negative or positive. That'll tell me if it's less than 0. And that is true. Negative numbers are less than 0. And that means this section of the number line gets shaded. Next, we need to test 0. 0 plus 3. 0 minus 4. 0 minus 1. Less than 0. That's a positive times a negative times a negative, which is going to end up being a positive, which is not less than 0. That's false. Next, testing +2. Okay, 2 plus 3. 2 minus 4. 2 minus 1. Less than 0. That's going to be a positive times a negative times a positive, which is overall negative, which is less than 0. That's true. And so then we're going to shade in between 1 and 4. That section is true. And the last number we need to test is 5. Here we go. 5 plus 3. 5 minus 4. 5 minus 1. That's a positive times a positive times a positive, which is a positive, which is false. Okay? So now that we've tested all of our test points, we've determined which sections of the number line are shaded, we can now go for the final answer, which is the interval notation. All right, so since the shading goes to minus infinity, we're going to start at negative infinity, and then the shading stops at 3. Now that's an open circle, so we need a parenthesis, and then we're going to put the union symbol, The shading picks up again at 1. Again, that's an open circle, so that's a parenthesis. And the shading stops at 4, open circle, parenthesis. And so this here in green, this is the final answer in interval notation. And I hope all of that was helpful. If you have any questions or comments, feel free to put them in the comment section below, or you can text me. And thanks for watching.